Through recorded history, I'm sure we have all heard the terms mechanization and robotics, right? But as the world changes, their place in society seems to shift, and movies like I, Robot are leaving us with more questions than answers. To hopefully clarify this and other related topics, please help me welcome Professor Tania Hanekom from the Department of Electrical, Electronic and Computer Engineering at the University of Pretoria.
Good morning, everyone. Yes, so let me just see, are we on, yes, okay, thank you very much. So, ladies and gentlemen, I would like to take you through where one starts learning about robots, okay? So, what is a robot? And I think many people have a lot of different ideas of what a robot is, but basically it's a piece of technology with maybe a little bit of intelligence built into it, or at least a few algorithms that make life easier for us, right? So why do we need robots? Well, we'll go through a few examples of what we can use a robot for, but I think most of us know by this time that you have robots in industry, you have even robots in medicine these days, robotic surgery, a lot of places where robots are actually helping us do things that people can't do that well. Okay, so we have brains that we can think about a lot of things, but there are other things that humans can't do that well. We, for example, not infinitely strong. A robot is very strong, or some robots can be very strong, and you can design them to do things that humans can't necessarily do. So I want to come now to a very important question. Who may build a robot? Okay, that's a very important question, because I think many of us sometimes think, well, you know, it's the Americans or, I don't know, somebody in Europe that can build a robot, but here in South Africa, you know, we maybe not that good with robots. And that is simply not the truth. I think in South Africa there is so immensely much potential among our youth that everybody that has an interest in robotics and technologies should actually consider moving into a direction where you can build a robot if you want to. So why would one want to build a robot in South Africa? Well, we have so many challenges in South Africa that can be addressed by robots if we want to, that it is a very good place to build robots. One of the things that we do use robots also for is to catch aspiring engineers. So you might notice, most people might think that most engineers are usually guys. I'm not a guy. I am an electronic engineer, and there are actually these days quite a number of ladies choosing to study engineering because you need a brain and not a beard. The beard is okay, but that's not all you need to become an engineer. Right, so we use robots in our undergraduate programs at the University of Pretoria to catch aspiring engineers, because you can catch an engineer in a trap with a robot. And using robots, we can make our education really interesting, so that engage students, so that they want to learn more about everything that is associated with a robot. So I want to show you a few things that we do at the university. So, let me first just introduce you to two of the robots that we have on campus. So that little guy with the big eyes is Loving Libby, our library robot. Is actually not a real robot. That is the mascot of the Faculty of Engineering, Built Environment and Information Technology. But Libby, that you can see there on the left, is our library robot, which can give information about library services to students that visit the library at the university. On the right, you see SMOOF, Smart Woof. That is civil engineering's, robot dog. And it has a lot of different sensors on it. They use it for road quality testing and just going places where people can't go. It's a very, very entertaining robot to see. It acts a little bit like a dog sometimes, it can sniff around and run around, so it's very nice to see in action. But it is very functional also because it can go places that people can't go, places that might be dangerous. It can carry a lot of sensors that can detect things like uneven terrain or things like that, measure data that we can use to improve things. Okay, so what do you need to know if you want to build a robot? There's a lot of things. You can see that slide is quite busy. So you need to know about microcontrollers, circuit boards, programs and firmware. You have to know how to create a structure where you can build this into. The structure is also functional in many cases, not just a casing to put everything in. There's motors, there's 3D printing, signal processing, sensors. There's so many things that work together to create a robot. So let me take you to campus and show you where we begin with our students. So one of the things that we started with about 10 years ago now is a robot race for the third-year students, okay? So in my class, I teach the microcontrollers module for the third-year electrical, electronic, and computer engineering students. And in my class, we build little autonomous robot cars, okay? And then we race with them. We race in a competition. They have to follow a colored line, not a black and white line, a colored line. And you know why that is? Because Google is good, okay? But you can't Google everything if you want to become an engineer. Then you're a Google-neer. That's not the same as an engineer, okay? So you have to understand what you're working with before you can be a real engineer. And that is the difference between relying solely on Google, which I guess many people can do if they're hobbyists and so on, and a real engineer that still needs to understand the basics of science before they can actually operate. Okay. So we call our little robots morphs, and a morph stands for a microcontroller-based autonomous robotic vehicle. And they have a color sensor on it. Okay, they have the students have to design that from scratch, so they can't go and buy it at some electronic shop. They have to design a navigation algorithm. They have to drive the motors, and then they like to make really cool chassis for the cars. I'll show you some pictures just now. Okay, so So, ladies and gentlemen, who said engineers are not creative? So you saw those wires and things, that's part of it, yes, but you also saw all the pretty cars that they're putting together. So it's really great to see creativity, also art, coming together with robotics in this case. So at this point, the students are introduced to the fundamentals of robotics together with the microcontroller course. Okay, let's move on. There you can see some of the very pretty cars that the students, oh, there's many, they're really nice. And you can see I'm wearing a race day t-shirt today, that the students also get at race day. Okay, so the Marvs, building them on campus is really a lot of fun. And eventually we then decided that we're going to start a robot school. So at the University of Pretoria, we also have a robot school now for learners, where we take children, or well, learners, high school learners mostly, and teach them just a little bit about where to start, you know, a little bit of 3D CAD design and so on. The nice thing about this is we presented at the University of Pretoria's community garden. So we're doing robotics in the garden, once again, inside the community, a lot of fun. Right, I quickly want to diverge now at the end of my talk just to another type of robot interaction, if you can call it that. So not only do we do robotics, the cars and undergraduate studies, but my research is about cochlear implants, which is basically a robot ear for people that can't hear, okay, for hearing impaired people. And there you can see an implant. Or the external part of a cochlear implant. There's a part that goes into the person and a little electrode array that goes into the inner ear. So there you have a picture quite close that you can see. On the right side, there's a computer model that we generated of the inner part of the cochlear implant. I'll show you a little bit bigger picture just now. So a cochlear implant consists of a sound processor, telemetry that signals the power and the speech signal through the skin, because you can't just have a plug behind a person's ear. So it has to go through the skin. Then there are implanted electronics as well as an electrode array that goes into the inner ear. It was quite nice that Professor Marwala mentioned multidisciplinary work. We work very multidisciplinary in this area because it's engineers, audiologists, anatomists, all working together, and of course also the ENTs, your ear, nose, throat surgeons that work together on something like this. So it's a very big type of transdisciplinary approach that one has to follow with this. And what we do is we like to address specific problems for specific individuals that have complications with their cochlear implants. So sometimes you get it that if the hearing nerves are being stimulated, then the person's face also twitches, and that of course doesn't work so well. So we're trying to see what can we do. We make computer models, and then we're trying to see how can we make that better so that the person in the end has the best possible hearing with their implant. So there are some of the computer models that we generate. On the left side, there's a computer tomography image of the inner ear, and with some of our outlines overlaid on that, and then the models that result from that, with which we investigate how people hear with these implants. So a little bit of robotic hearing also in this talk. And that is what I have for you this morning. Thank you very, very much for inviting me. And if you would like to contact us, you will find our information on the Department of Electrical, Electronic and Computer Engineering's website. Thank you very much.